Hi, in this video I will show you how to use an inertial measurement unit IMU and attitude heading reference system to provide an accurate heading estimate. So this is the Minimo 9 from Pololu. It has 3-axis magnetometer, 3-axis gyro and 3-axis accelerometer. And I'm connecting this IMU with Arduino Micro through I2C communication. Measured data from the IMU can be used for estimation of angle of rotation or 3D orientation. In this video we will use a sensor fusion algorithm, which is well known as a Madwig algorithm or Madwig filter. The result of this project is to compare orientation estimation represented by quaternion and by Euler angles. So let's do it. Okay, firstly we have to calibrate the IMU. We can start with magnetometer. So we will rotate with the magnetometer in XY plane. So let's do it. As for magnetometer, problem is that we have to find out the minimum and the maximum values of the magnetic field around the sensor, because there are computers, there are wires, there are other devices which have a big impact on the magnetic field around the sensor. So that's the problem. Okay, let's do the same in the XZ plane. Okay, the calibration of magnetometer is completed. Now we can calibrate the accelerometer. As for gyro and accelerometer, these two sensors are affected by an offset, and that's the problem. As for an accelerometer, the IMU remains at rest, and the vector sum of the forces should be equal to G. So we will let the accelerometer in 3 different axes, and the sum of the forces should be G. So let's do it. For Z axis, for X, for Y. Okay. And now we can calibrate gyro, and the same goes for a gyro. So we let the gyro, we won't move with the gyro, and the angular velocity should be 0. So let's do it. Problem of gyro is that for a long time of measurement, the evidence of the continental drift is obvious on a gyro, so be careful with that. So we calibrated the sensor. Now we can start with moving with the sensor and get some data from it. So let's do it. So measure data for each sensor are shown in the figure. Here you can see the measure data from gyro. It's in the degrees per second. There's accelerometer in G, and there's a magnetometer in microtesla. We can see that the measure data from magnetometer isn't so good. The problem is that the sampling frequency of the magnetometer is too slow, so that's the problem. So we can animate this movement. On the figure below we can see the Euler angles, which were determined using a Madwig algorithm, and here you can see a problem which is known as gimbal log for angles for Euler's angle. This problem will be shown in the animation above. It will be clear. So on the right side there's a figure for orientation estimation represented by Euler angles, and which occurred by gimbal log. And in the figure, or on the left side, we will see the orientation represented by quaternion. So let's do it. Here we can see in this second, yeah, there was clear that the problem of Euler angle, which is known as gimbal log, there was evidence of this problem. So that's it. This is the end of this video. Thank you for watching.